what we have on the table is the familiar dual supply. I am sure all of you are now familiar with this. We have already seen the earlier experiments. You have the breadboard. In the breadboard there is an op amp and there is one feedback resistor. The wiring is done and the output voltage is measured using this digital voltmeter you find here. This digital voltmeter, which is selected for the voltage range, DC voltage, will measure output voltage. Now the circuit of whatever that we have wired on the breadboard is shown on the diagram above. Just to recapitulate, it is just a simple, you have a current source here, you connect a feedback resistor of 10 kilo ohms and you measure the output voltage using a digital voltmeter. This is the same circuit which is wired here, and what I have here is a current source. It is a commercial current source, but one can also do with simple circuits in the lab to generate constant currents, and this is capable of producing currents through very large ranges starting from nanoamperes to several hundred milliamperes by using the dials. Now right now I have kept it in standby mode, so the current, this circuit current source is connected to the input and that current flows into the pin number 2 of the amplifier, and the output is monitored here. To measure the current, I have introduced a current meter, another multimeter. I have selected 200 microampere range here, and therefore what it measures is the input current. This comes in series with the current source and then it is applied to pin number 2. This black wire is connected to the pin number 2, so this is actually connected, these two are connected in series at the input. This is the current source, this is the current meter which is measuring the magnitude of the current, and the voltage is measured using the output voltmeter. Now let us try to apply the current. So I don't know whether you are able to see the dial. It is 2 here, it is 0 here, and this is the dot decimal, and therefore 20 point, that is microamperes, so it is 20 microamperes, and that is the current, and you can see here it is in 200 microamperes range and it reads 20 microamperes. 20 is the reading here, so this and this are perfectly matching. You are applying 20 microamperes and you are also reading 20 microamperes in the multimeter, and that is being applied here. You have a 10k resistor, so multiply 20 microampere by 10k, that will be 200 millivolts. The k and the micro will make it milli, so 200 millivolts should be the value of the voltage. I am sure you are able to see here the voltmeter reading is, how much is it? I have to switch on the dual supply, okay, and if you observe the multimeter, it reads 206 millivolts. So this is a very neat presentation. You can see that. Now what I am going to do is I am going to increase the current from 20, let me increase to 30 microamperes. So you can see this current meter reads 29.9, which is 30 microamperes, close to that, and correspondingly if you now observe what is the output voltage, it will be very close to 300 millivolts. So now I keep moving to another voltage current 40 microamperes, 39.8 is the reading here. You multiply by 10k, you get there, it is about 406 millivolts or so. So you can see this current is converted into voltage. Now if I change the range, for example I will bring this to 0 and have 1 or 2 microampere. For example I have kept 2 microamperes here. 2 microamperes multiplied by 10k should give me 20 millivolts. So what you get on the millivolts range is about 21.4. There is a slight variation, it is not perfectly 20 because this 10k resistor is what I read from the color code, but the actual resistance can be slightly different from 10k, maybe 9 point something or 11 point. There is a 10% tolerance and therefore it can be slightly different from 10k. So if I want to change the conversion factor, the conversion factor is basically the 10 kilo ohm. that is a trans resistance amplifier. So if I change it to 100 kilo ohm here, immediately you will find the same current will be multiplied by 100k and you will get the corresponding output voltage here. So you can increase or decrease this resistance here and get a voltage proportionally at the output. Therefore it is a very simple and useful circuit, especially when you have for number of different sensors. I also told you that we will show you a simple application circuit using LDR.